All right. Oh, there are my slides. Perfect. Okay. Well, as Anthony mentioned, I was involved in the DOE report, and I'm going to go over the economic findings in our report. And let me just see if, yep, that moves us forward. So I'm going to talk about the material there on economic growth, agriculture, climate impacts, and the social cost of carbon. I want to begin by quoting from a previous IPCC report. This is the 5th assessment report, Working Group 2. And the conclusion from the economics chapter in that report led off with the following quote: "For most economic sectors, the impact of climate change will be small relative to the impacts of other drivers. Changes in population, age, income, technology, relative prices, lifestyle, regulation, governance, and many other aspects of socioeconomic development will have an impact on the supply and demand of economic goods and services that is large relative to the impact of climate change." Now, when I've read that, I thought, that list covers everything. What they're basically saying is, climate change will be small relative to everything else that's going to happen. And so in our report, after going through it, I thought, well, all we're really doing is updating that and saying something pretty similar, that yes, climate change may have effects, but they're going to be small compared to everything else that happens. Now, I don't know if we can move to full screen mode so that everybody can see. The first issue we look at is the connection between climate change and income. And if you picture an inverted U-shaped curve between temperature and income, the usual pattern that we find, or that we expect to find, is that warming would be beneficial in relatively cool countries, but past a certain point, it's likely to be harmful in hot countries. However, the overall net change at the global scale is going to be pretty small. There'll be benefits in some places, costs in other places. And I had, in the chapter that was published by the DOE, I hadn't referred to this study by Richard Toll in 2024, a big literature review that he did. But Richard was one of the critics in the Dessler group and said I should use more up-to-date citations, so I just take the quote from his paper here, which is, "Researchers disagree on the sign of the net impact, but agree on the order of magnitude. The welfare loss or gain caused by climate change is equivalent to the welfare loss caused by an income drop of at most 10%. A century of climate change is not worse than losing a decade of economic growth." Now, to put that in perspective, Canada has lost a decade of economic growth, but not due to climate change, because of bad government. But it's not the end of the world. It's, in fact, a lot of people wouldn't really notice unless you showed them a graph of it. And this is going to be in the context of a century of economic growth, where you have income growing by many multiples and even tenfold in places. So this, again, is what the mainstream literature shows. The impact will be small relative to everything else that happens. So this is the graph in Richard's paper, just plotting what's out there in the literature. On the horizontal axis, you have warming. On the vertical axis, you have the percent change in income. And that central black line goes down at a rate where you lose roughly 1% of income per degree of warming. So, and again, in the background, you've got 100% income growth, so these are tiny changes. 2 or 3 degrees of warming, 2 or 3 degrees income loss relative to the base. Again, it's small compared to everything else that's driving economic growth. Now, the standard finding in the literature has been also that it's a one-time effect. A one-time 1 degree warming, 1% income loss. And as a result, when we put this into what are called integrated assessment models, the loss due to the warming is very small compared to the loss due to trying to prevent the warming. And so the optimal policy that comes out of these models involves only very modest abatement activity. Once the costs begin to mount of trying to reduce CO2 emissions, it very quickly is a net loss to society. The most recent version of the DICE model, which is a very famous version of William Nordhaus's model, it projects 3.1% loss of income due to warming as of 2100. But that, again, it's comparing against the SSP scenarios where you've got income growing between 2 and 16-fold, depending on the scenario and the regions around the world. So it, once again, small compared to everything else. Now, in 2012, there was a study by Dell et al., led out of Harvard, where they looked at whether warming might also impact the economic growth rate. And they found, in their analysis of a large panel of data, there's no effect in rich countries, but in poor countries, warming causes a slowdown in the economic growth rate. Now, once that happens, now you've got these big compounded effects, and you plug that into a model, and suddenly the social cost of carbon grows quite a bit and starts to justify aggressive mitigation policies. There's been a lot of literature on this since then, and one of the early papers, Burke et al., they said, yeah, we found the same result in hot countries, but a subsequent reanalysis of the Burke et al. Data in 2021 showed that that result's very sensitive to choosing a specific functional form. More generally, the data doesn't support that finding. It's just lost in the noise. Reanalyses of the Dell et al. Data has found, again, there were outlier effects and problems with their econometric work. Once those are fixed, the effects disappear. And then replication work on new and larger data sets, including a study I published with a grad student last year, there's just no effect there. It's a tiny effect overall. It's actually slightly positive, but it's not statistically significant. So the issue on growth is we can't really make a case there. On climate change and agriculture, there's a literature there based on looking at land value changes over time. And there is evidence that came out there that warming drives down agricultural land values in some places. It improves it in others. But in the US, overall, it looked like it drove land values down. However, another study looked at the issue of land value. It's picking up a lot of influences other than just temperature. If you look at the rents paid on agricultural land, warming turns out to be a beneficial effect. So that might be identifying the actual agricultural impact better than the land value. And then, I won't go into it, but studies have questioned whether US farmers are actually adapting to warming. But the problem there is the US government subsidizes crop insurance so heavily now that farmers don't really have to adapt to weather risks or warming because they're paid either way. So there's a moral hazard issue there. Crop models, when we look at the issue of CO2 fertilization, which is actually missing from a lot of econometric studies on this, generally the picture is that crop models will say warming's bad, CO2 is good, precipitation doesn't really matter one way or the other. There were a couple of studies using the same data set beginning in 2014, 2017. The 2017 version of that analysis said that there will be huge negative effects globally from climate change, CO2-driven climate change, and that was influential on the Biden administration's decision to hike the social cost of carbon. I couldn't figure out, though, why the 2017 study had analyzed the same data as the 2014 study, but got completely different results, because the 2014 study said, no, the two effects roughly cancel each other out. So I got the data and reanalyzed it myself and found that the data set was missing most of the CO2 measures. And so when I went to the underlying sources and added them back in, reran the 2017 model, then the losses roughly disappear. So the outcome changed from the blue line sloping down. So again, it's warming on the horizontal axis, yield change on the vertical axis. And you can see the original study, there are losses at every temperature level. But then once once I put the CO2 data back in, it moves up to the green line, which shows either no change or slight gains, even as far out as 5 degrees of warming. So that was a case where the data set was incomplete, and that affected the results. We look at managing the risks of extreme weather. Here, the story, it's well established in the literature, but cold is deadlier than heat. And so we cite a few studies on this, global studies, there's US studies. It's not really a controversial point, although, you know, we could have said there are 7 days in a week, and we'd have been flooded with criticism, given how people lost their minds over this report. But cold much deadlier than heat, which means that if you shift the temperature distribution up, yes, you will have more mortality at the warm end, but you will have a loss of mortality at the cold end. And so that was really one of our points, because there are lots of studies out there, and I'm sure you'll switch on CNN any night of the week, and it'll tell you that some new study has come out that says there'll be more deaths due to warming because there is a mortality effect during heat waves and during hot weather episodes, but they always leave out the other end of it, which is, okay, but if you're going to shift the distribution, tell us about all these cold weather deaths that will be prevented. So now on this subject, though, the key either way, whether cold weather or hot weather deaths, the key to resiliency is keeping energy costs down. And so we discuss about the studies that have shown that when energy costs go up, yes, the wealthy, they don't care, but poor households have to cut back on cooling and heating in their homes. And so these mortality effects are hitting the poor households. And so key to preventing that is keeping energy costs down. Okay, on to the social cost of carbon. Now, there are some people that just don't want to talk about it at all, and I can understand the complaints. I think of it as it's just a big if-then statement, okay? You've got a model, a bit of a black box, but you put a bunch of assumptions in one side and a number pops out the other side. And so if all this list of assumptions hold, then the model says the magic number is 50. Sort of like Hitchhiker's Guide to the Universe, you know, the answer is 41. And so all those assumptions that you put in one side, they're not validated one way or the other by the number that pops out the other side. You have to discuss the validity of those assumptions. So that's where our attention is. If you choose a very low discount rate, so future damages count heavily towards the present, then you'll get a higher social cost of carbon. If you assume a high climate sensitivity, you get a high social cost of carbon. And on down the list. Now, in the original version of the report, I hadn't gone into some of these in as much detail as I should have. I have actually revised the chapter, but due to the wisdom of the court, I'm not allowed to share this with you. But anyway, we can go through the list and basically make out the case why the most secure assumptions to put in on the left side of the model will typically give you a fairly low social cost of carbon. Not zero, but it's low enough that we're right back to the quote I said at the beginning, which is even if you fully priced this supposed social cost, it doesn't affect the economic growth path because no one's going to eliminate fossil fuels due to a calculation of the social cost of carbon. Okay, so, and this has been the story from day one. You know, I've been about 30 years working in climate economics, and this just keeps coming up as a story. If you want to go the social cost of carbon route, you use reasonable assumptions, you get a social cost of carbon that raises the price of fossil fuels slightly, but not enough to seriously change the use patterns of fossil fuels. Okay, so to summarize, the data we have comes over the past 100 years or so. And while the world warmed, you can see the top left chart, those are the yields of important staple crops around the world, just marching up year after year. On the right, those are climate-related disaster deaths, which have collapsed to extremely low rates. And the bottom left, that's real income per capita around the world. Some parts of the world has just grown remarkably over the entire 20th century. Some of them it's more recent, the growth pattern has kicked in, but while the world warmed, a lot of things improved and got better and continue to do so. So I would say that that quote from the IPCC in 2015 holds up very well. There will be impacts, but they will be small relative to everything else. So that is the economic content of the DOE report. Thank you.